normal. Is this a true or false? Is this statement true or false?
Yes. I have to explain. It's called the normal score. Yes. And yes, the statement is true. Yes. I'm not going to ask you to use the formula and calculate any of that. So we are going to determine everything with StatCrunch here. So yes, that is correct. I needed to intervene because we didn't get the chance to talk about that. So you may want to write it down, right? So it's good to write it down. A normal score is the expected z-score of a data value, assuming the distribution of the random variable is normal. So the normal score is that. Okay. Who would like to work on the next one?
I can do it.
Good. Thank you.
What is the purpose of constructing a normal probability plot?
Excellent. Who would like to help with the answer?
A.
If it is reasonable to assume that sample data are from a population having normal distribution. I agree. Easy to determine? No. No. Normally is used to determine if the reasonable is to assume that sample data are from a population having standard normal. No, of course. Thank you very much. Good. Who would like to give it a try for the next one?
I can do it.
Okay, thank you.
When working with normal probability plots, straight lines indicate normality,
Excellent.
while curves represent non-normality.
Perfect. Excellent. Okay, number 3.
Read it.
Okay.
The normal quantile plot shown to the right represents duration times in seconds of eruptions of a certain geyser from the accompanying data set. Examine the normal quantile plot and determine whether it depicts same data from a population with a normal distribution.
Excellent. So again, the normal quantile plot is the same, with the normal probability plot. Okay. We don't need to view the data set. There is no need because we have the normal probability plot right here.
Can I also answer?
Yes.
Is it C?
Yes. So the distribution is normal. The points are reasonably close to a straight line and do not show a systematic pattern that is not a straight line pattern. Excellent. Thank you.
I have a question.
Please.
What if it's like a straight line like that, and then you have a random outlier somewhere?
If
like,
it's
away from the line,
depending
it's
on how many they are.
So,
Depending
like
on
if
how
it's
many.
just one,
If it's
still
just yes, if it's a small number, yeah, it's okay. Depends again on what the study is all about. If we're talking about the length of pencils, or we're talking about human life. So maybe I'll say if I have that, I will investigate the outlier. I will not remove it, but I will investigate to see if it's a mistake. And I may have to conduct the study a second time to convince myself that I did the right thing. Again, if we're talking about concentration of a potentially deadly chemical, who knows, whatever. Yeah, that's everything counts to the T. But I wouldn't discard the outlier. I will investigate it and maybe conduct the survey the data or collect the data again. Okay. Anyone would like to try number 4?
I can do it.
Good. Go ahead.
You can answer it. All right. Estimate the normal type plot and determine whether is there is similar data from population with a normal distribution.
So let me help you with so let me help you with this, enlarging it a little bit.
Is it D? No, the points do not lie close.
Right, I would say that. The points exhibit some systematic pattern that is not in a straight line. So the kind of a line, but the pattern of the points is reasonably close to a straight line. I would say no. It is close to a straight line, to be exact. Just these two are outliers. So that's a very good question. We just talked about that. So just two outliers. The rest are close to a line. Just these two are outside. Anyone else has other ideas?
I think I'm with you on this one.
The pattern of the is reasonably close to a straight line. So what we use, there are other softwares that show a range. I'm not sure if StatCrunch shows that. Normally it's a range where the data should be, not just to say, okay, is it close to the line or not? Okay, so let me stop sharing for 1 second and just show you what I mean. So something like this. This is kind of a range. If points are here and here, I'll say not normal. But if the majority of points are inside the acceptable limits, I would say that the normal probability plot shows that you can use the normal distribution for something like this. Okay, but if they are a lot outside of this range, then no. So again, we saw that this book has its own standards sometimes. The z-score, as we saw, another z-score, the z-alpha, is not what normally is considered, but they are twisting it. So I would go with this, but I don't think it's 100%, to be honest. I would look into more of a more details about the information about the data set that I have. So here they want us to use the normal probability plot, so we have to do that. So we go to, again, 5, assessing normality with 5 entries. No, that's never acceptable. You can never assess normality based on 5, but that's okay. So let's take a look. And I want the normal quantiles to be on the y-axis. Yeah, I would say that this is close enough. Close enough. So
A C.
a C. Very good. Okay, 2 more here. If oh, there is something. Okay. So this is quite close. I wouldn't say that it has any outliers for this data set. We can enlarge it here too. I wouldn't say that because it's within the range. They're not using what I would have used, but that's okay. Okay. Oh, there is another part. So who would like to give it a shot? To part C?
Would it be C?
So since the relationship,
Say C.
good, since the relation between the expected z-values, right, then and the observed values is approximately linear. I agree. The other, yes, since the relationship between the z and the observed values is not linear, of course. Good. Good. So let's see 6 and 7. construct a histogram. So I have to click, open the StatCrunch, and create a histogram. Remember how to do that on the graphs. Here's the histogram. Now, always when I do that, I have to look and see how many classes they used, right? Because it was not going to look the same if I don't change the number of classes, if I don't give the range, if I don't tell the StatCrunch where to start and what is the width. StatCrunch is not going to give me exactly what it's. I know. StatCrunch is not going to give me exactly what. So see, StatCrunch used 2, 4, 6, 8 classes. And here we have 5, and here we have 5, and here we have 5. So I had to do some arithmetic, right? Look at the range, determine the range, divide, blah, blah, blah. Obviously, it's not this. So which one of these two will definitely eliminate? This one, right? So it has to be B. But again, StatCrunch created a histogram with 8 classes versus 5. So be careful with that. Okay, so let's answer, construct a normal probability plot. So I have to go back. Where's my data? Right here. And with this, create the normal probability plot. And I want it to look like that. See, Z, right? The normal score is up here on the y-axis. That's why. Otherwise, for some reason, StatCrunch will do it the other way. Okay. And compute. And what do you think about this?
I think they're pretty close to the line.
Yes.
It would work.
I would agree. Yes. Pretty. Not too bad. And now it's going to probably ask us, is the histogram and the normal probability plot of the data to assess normality? So now, should we use normal distribution, or we should look for a different or a transformed variable? Who knows? Anyone who would like to give it a try?
I'll give it a try. I think we can use the normal plot because it's close to the line.
Yes. So which one we choose?
Maybe A, but I wasn't too sure about the histogram.
No, that's true. That's true. But when we looked at the histogram, is my histogram still here? Yes, it's right here. Results 2 hidden. Histogram. So you're right. Oh, I didn't mean to color anything. Okay, now I have to color everything. Okay, fine, happy. So you're right. I'm not very happy with the histogram. But if we look at what they had here, with 5 classes, I will still agree with you. It's not very normal, symmetric, bell-shaped. But the normal probability plot implies normality, but the histogram implies the data is not normal. I would still go with D. It's normal probability plot imply, but the both imply the data is normal. It's kind of bell-shaped, not 100%. I wouldn't say that the histogram implies that the data set is not normal. I wouldn't say that necessarily.
So for the histogram to imply that it is normal, it has to be the bell-shaped, right?
Yeah, kind of bell-shaped. This is not bell-shaped, right? So these are kind of, I'm stretching it a little bit. Again, it's a matter of interpretation. They may say, but it really has to be skewed. If the normal probability plot is quite nice, I would say, well, the histogram is not very far away. Now, if this says, oh no, something like this, even the histogram shows, kind of normality, I would not choose that. Okay, one more question. Oh no, we're done here. Okay, so let's continue with chapter 8. And in chapter 8, we're going to talk about something called sampling distributions. Let me